In Chapter 13, we learned about the basic structure of the heart and the path that blood takes as it travels through the heart. And we also learned about the electrical activity of the heart initiated by those pacemaker cells on top of the right atrium. What we need to do next is go on and consider what are some of the consequences of that. The consequences of the electrical activity is that the heart muscle beats. And as a result of that, we end up having blood flow, right, out from the heart into the rest of the body. So we are going to start this chapter by looking at cardiac output. We're going to be doing a fairly distilled version of chapter 14, just to give you a heads up about that. So we'll be focused on three key things: cardiac output, blood flow, and then finally blood pressure. Starting with cardiac output. Cardiac output is a measure of how much blood is pumped out of the heart over some period of time, specifically in 1 minute. Cardiac output is a result of two things: the stroke volume, which is just how much blood leaves the heart per beat, and then also how frequently is the heart beating, so the heart rate, beats per minute. If we take those two things and multiply them together, we will get the cardiac output, a measure of how much blood leaves the heart per minute. So on average, if we just consider some sort of ballpark figures, if we consider a person and their average heart rate is 70 beats per minute, again, there's quite a bit of variability in this from one person to another, depending on fitness levels and other factors. But if we take an average heart rate of about 70 beats per minute, and then if an average stroke volume, so how much blood is leaving the heart per beat, if that's about 70 to 80 mils, if we multiply those two things together, we will get an average cardiac output of 5,500 milliliters per minute. Think about that number. This is saying every minute, 5.5 liters of blood is pumped out of the heart. If you recall from the last chapter, from chapter 13, we said that an average adult has in total about 5 liters of blood. So this is amazing to think about what the heart is doing every minute. It's essentially making all of the blood circulate every minute. So the cardiac output, this is something that is influenced by several key things. We're going to focus in on some things that influence stroke volume and some things that influence heart rate. Let's start with heart rate. So things that will influence this one right here, the heart rate. Okay, so we know that the heart just on its own will beat. It's a muscle, right? So the pacemaker cells initiate that depolarization, and the heart will beat just on its own. However, the rate can be influenced by the autonomic nervous system. So just by way of a reminder, the pacemaker cells in the heart, the pacemaker cells have this spontaneous depolarization that takes place. Those HCN channels open and let sodium through. That leads to a threshold and action potential. What the innervations of the autonomic nervous system can do is alter how quickly that happens. The sympathetic division of the autonomic nervous system, remember that's the one that's the fight or flight response, activates fight or flight responses. So if the sympathetic division is activated, what it's going to do is increase the heart rate. The way that that happens is just by causing these HCN channels to stay open. So in that case, it doesn't take quite as long to reach threshold. It happens more quickly. That's due to the effects of the sympathetic division of the nervous system. The parasympathetic division, on the other hand, remember that's the rest and digest division. It uses a different neurotransmitter. Parasympathetic division uses acetylcholine, which causes potassium channels to open. So remember back with membrane potentials, sodium and potassium, their gradients are in opposite directions. So if potassium channels open, then potassium is going to be flowing in the opposite direction from sodium, and so it's going to take longer for the sodium leakage to end up leading to threshold. So it elongates this section of the graph, and as a result of that, spreads out the heartbeats. So that's the nervous system influencing heart rate. There are some things that influence stroke volume as well. Let's take a look at some of those. The stroke volume, again, this is how much blood is being ejected from the heart per beat. And that stroke volume, there are really three key things that we're going to be focused on. Number one, the end diastolic volume. What this is it's a description of how much blood is sitting in the ventricles right before the ventricles contract. So at the end of diastole, so at the end of the resting phase, how much blood, what volume of blood is sitting there in the ventricle. Okay, the larger the volume of blood, the more strongly the heart will contract, and so that's going to increase the stroke volume. If there's not as much blood sitting in the ventricles, the stroke volume will be lower. It will decrease as a result. So that's one thing. Number two, the total peripheral resistance. We're going to come back to this one in the next video. This is referring to resistance that exists all throughout the rest of the body. You can, if you've had physics, you can kind of think of this as a circuit. So depending on how much resistance there is in the circuit, that's going to influence how much current is flowing or how much blood is flowing from the heart. The higher the resistance out in the blood vessels, the more difficult it is for the heart to get blood out in circulation. And so the lower the stroke volume would be in that case. If there's a lot of resistance, not much blood will be pumped out. Number three, the contractility. This is referring to how strong the ventricles are. The ventricles, the heart is a muscle, and so depending on the strength of the muscle, that's going to influence how much blood can be pumped out per beat. Ordinarily, in a normal healthy heart, about 60% of the blood in the ventricles leaves every heartbeat. So that's kind of an interesting note. It's not like all of the blood gets squeezed out of the ventricles. It's about 60% in a normal healthy heart. There is a law that kind of ties together some of these concepts, the Frank-Starling law of the heart. What this does is considers the end diastolic volume, so how much blood is in the ventricles right before they contract. And it turns out, and I already said this earlier, but the more blood there is, so the higher the volume, the higher the stroke volume will be as a result. And this ties in with the nervous system. And the greater the volume of blood in the ventricles, the more active the sympathetic division of the nervous system will be. And so that ends up leading to a stronger contraction of the heart muscle, and that in turn leads to a greater stroke volume. So that's the Frank-Starling law that pulls all of those concepts together. So to recap some of these ideas, let's look at this summary picture. So again, we're talking about cardiac output, how much blood is put out from the heart, and that is influenced by two things. Cardiac output, how much blood is put out per unit of time. Okay, it's influenced by two things, cardiac rate, stroke volume. For each of these, there are things that can promote or things that can inhibit. So cardiac rate, we can increase cardiac rate with activity of the sympathetic division of the nervous system. We could decrease cardiac rate by activation of the parasympathetic division of the nervous system. Coming over to stroke volume, some things that increase stroke volume would be how strong the contraction is. The stronger the contraction, the greater the stroke volume. The greater the amount of blood sitting in the ventricles, the stronger the contraction will be, so that's going to increase the stroke volume as well. And then finally, what is it that decreases stroke volume? Resistance in the blood vessels. So again, we'll be coming back to blood vessels in the next video.